Well, since we're here, bottom of the hour, 10:30 Pacific, you are listening to Postgres Day 2024, brought to you this year by Crunchy Data, home of professional enterprise Postgres support and makers of Crunchy Bridge, the cloud Postgres service for the discerning nerd. And now, Crunchy Data Warehouse, a cloud analytics solution for the discerning data cruncher. Our next speaker is a colleague of mine from Crunchy Data, Rekha Khandhadia. Good to have you here.
Thank you, Paul. Thank you, Elizabeth. So I'm Rekha Khandhadia. I'm a solutions architect at Crunchy Data. I've been working with PostGIS for almost 6 years and helping automotive industry with Postgres and PostGIS initiatives. I do have an overlap with Overture Map talk that just happened one talk before, and well, let's see how it goes. So my conversation with GeoParquet started with, I wanted to understand what GeoParquet is. I wanted to understand why it performs the way it performs. What is the nuances, the structure nuances that support the fast analytics. And so we will do a technical deep dive onto GeoParquet files and the processing. I will also do a geospatial analytics in Crunchy Data Warehouse. I will do a kind of a demo that shows how easily we can ingest GeoParquet data and seamlessly work with Postgres and PostGIS. So let's go on through GeoParquet. As everybody knows, it's an based on Parquet, and Parquet was built for big data analytics, and it was released in 2013, almost 11 years ago. And GeoParquet is based on that, and it was released by OGC in 2021, so fairly new. And we, so it's Parquet is an open data source, columnar data source offering, and columnar data means you're storing your column data into a continuous memory location. And, it also provides lot of different compression algorithms and encoding schemas, which compresses your data from large data sets to a very compressed data set. And the compressions, like it supports Snappy, ZZip, and Z standards. Encoding schema is like translation of your data into, in XML words, enumeration, or in a relational world, it's a type tables that we use to, decode and encode our data. Because it does a lot of compression right out of the box and encoding, the retrieval, and it's an efficient storage, plus the retrieval of the data is very efficient as well, because you're only retrieving the column data that you need. And we just heard about predicate pushdown, so I want to just hammer that a little bit more. This is high performance. What you're doing here is you're sending your filtering condition closer to where your data resides. Hence, you're going to only move the data that you need. And that has a lot of efficiency there. Now, coming back to the GeoParquet, adding this geometry thing, as well as geometry columns and the bounding boxes. That is one of the big things that is part of this standard that adds additional efficiency for querying geospatial data. It supports complex types and nested. This is arrays, list, record structure. So this is a big thing. You don't have to sometimes not to worry about the schema changes that happen on the fly. And since Parquet has been around since 2013, there are a lot of widely supported analytics tools that are available for you. Okay, so let's go through what the file structure looks like, right? And many of you have seen this in cloud native geo pages. Here you can see there are row groups. Now, row groups, you need to think in terms of horizontal partitioning of the data. And here is your columns chunks that are specific. All these column chunks reside within a row group. And that is very important because you're saving the data. This is at the Parquet file, and you're looking at the data very closely as a columnar store. Here is your geometry. You can see where the values are there. Now, this is the file metadata is a very important aspect, right? Because it stores all the statistics for this file. It shows what information the row group is capturing. It shows you, it captures all the min and max value of each of these columns, as well as files and the row groups. So I wanted to understand further, how does really the GeoParquet file look like? And because if you understand this, then you can start either creating your own files and also understand how you can do, why it will work or perform better. So I took a county shapefile and took OGR to OGR tool, took the county shapefile and converted into a Parquet file. And I use a utility called GPQ to look at what the structure of the Parquet file is, right? And here you can see, sorry, it moved. Here you can see the compression is snappy, the data types. Here you can see how many rows it has captured. And this one is a small file, so you'll only have one row group, right? And here is the bounding box that Jake was talking about. This is the efficiency for geospatial queries, right? And this geometry is well-known binary. It supports all the vector data types, right? So now, since you already got exposed to Overture map, let's look at that as well, right? So Overture map places schema. I took one of the files and I wanted to use and look at it in more detail. So here are the number of rows and here are the number of row groups. And here you can see the complex data types that are there, and it uses a standard Z standard compression mode, right? And here are your bounding box. These are very important pieces because you will understand why GeoParquet performs well on large data set. Okay. I'm having trouble with my moving something. Okay. So I wanted to take a little bit more detail into it and look at the file metadata, right? So I use another tool called Parquet, CLI, and you give Parquet meta and the file name. It gives you information of what the row group number is, number of counts in this row group at the starting, what is the size of the record and what is the compressed and uncompressed size. But more important of all of this is this min and max, right? For geospatial queries, you're looking at the bounding box min and max, and you will see an example of how I'm doing this. But just to point out, this is min and max values for each of these columns. And here you're seeing the complex data structure types as well, right? And this is where GeoParquet shines, right? Okay, so how would the GeoParquet query processing work, right? So what happens, it reads the footer of the file metadata. It adds the filter on the row groups. So it says, okay, I want to, if you have a query says, oh, I want to do a bounding box for Michigan, and you do that, it's going to only get those row groups that matches that bounding box query. And you will retrieve whatever relevant column chunks that are associated to that row groups. And then return the result set. Because GeoParquet has recently gained a lot of attention, and so, a lot of open GeoParquet data sets have been released, which allows us to really, in our system, leverage all this data without, worrying about how to ingest different sources, right? So, also, a lot of software support for that has been also there over time. GeoArrow, GeoPandas, QGIS, Apache Sedona. And of course, you saw the OGR2 OGR has a lot of support. With this also came out a new OLAP database, DuckDB, which is a high performing OLAP database. And also we ourselves at Crunchy released PG Parquet recently to support all the Parquet processing. So now I'm going to switch back, since GeoParquet has been a major run, and with that came a lot of new tooling. We are a Postgres company and we are a PostGIS company. We wanted to build something that takes all of this processing and seamlessly integrates. So we introduced Crunchy Data Warehouse. Before it was called Crunchy Bridge Analytics. So it has a seamless integration with Postgres PostGIS. It seamlessly integrates with DuckDB. It can query remote data files, which are GeoParquet, JSON, CSV, shapefile as a foreign tables. Support, because now that you're doing GeoParquet and all of that, you have a complex data type and structure thing. And then you can also, it allows you to import and export from your data lake. We recently added iceberg tables into Postgres, which we write to iceberg tables and can also read iceberg tables. Again, since GeoParquet supports predicate pushdown, we leverage DuckDB to do the predicate pushdown. Again, this is a filtering condition that you're pushing closer to where your data resides. We have vectorized execution. This is another optimization technique that is efficient, allows you to do efficient CPU utilization. We do push down parallel. And here is NVMe, which is another fast new SSD standard for high performance SSD thing. So now that I have this, I wanted to see how my GeoParquet and PostGIS data pipeline would look like. So I take a Parquet file and I look into this data warehouse. Here will be PostGIS, Postgres, and all seamlessly integrated. You don't need to do a whole lot, right? And then I will show you how it integrates. I don't have PG feature server tile server, but I do have QGIS demo for you to see how seamlessly it integrates. So here is a demo, but it's a more of a screenshot demo. So first thing I'm going to do there is create a foreign table with overture map places. It's a GeoParquet files. I'm going to view what the table and column structure is going to look like, create materialized view, and then do a PostGIS nearest neighbor search for parks. I wanted to find out parks that are near the school. And then, QGIS, I wanted to see if I'm playing golf, then, which are the coffee shops that are within 1 mile of the golf course. So, okay, so this is here, you can see, I'm going to play this. Here is my overture map SS3 location, and like Jake pointed out, the theme is places, the type is equal to, I want to take all the types and I want all the Parquet files. And you create simply by saying server Crunchy Lake Analytics, and it's going to create a foreign table. And here you can see the geometry. So now we're going to look at the table structure where it's showing you the geometry and also showing you FDW options down below. I'm going to take a complex structure type and you can see how it is done. So this took like few minutes and you already have access to Overture places. Then I'm going to just create a materialized view, as I said, and basically the bounding box for Michigan. And I'm also creating an index file, gist index on the geometry. And of course, I have done a conversion to do 4326 SRID. Okay, so it took 5 seconds to create this materialized view. That means you have moved the data from your S3 voucher map to PostGIS within 5 seconds. Now I'm going to do a nearest neighbor search, basically telling, I need to find parks and near the school. It's a very common query that we always do, and it shows you the distance. I calculated the distance as well as there is a school location and the park location. If I look at how many parks, here's something that we need to bring to Overture Map is showing more than the Michigan. And I realized this, but I decided to still show. So basically how simple it was to get the data, do your analysis via pgadmin. Here is another, this is a QGIS display screen that I'm going to show you. Here is the golf courses in Traverse City and coffee shops. The bounding box is for the Traverse City in Michigan. And I want to find all the coffee shops that are less than 1 mile. This is the golf geometry that's trying to load in QGIS, and you can see the location. And I'm going to try to format so that we can display the name of the coffee shops and the name of the thing. It's a very simple example. What I'm trying to point out here is so seamlessly integrated. We don't need it to think about any other language other than the SQL and the tool, the QGIS, which is most popular. You can use that out of the box, and no new technologies to learn. And it's high performance, right? I mean, can't beat this. I'm so pretty excited about this. I can't wait to do more complex stuff on this. It's just too exciting. All right. So this was in few seconds, I have everything done. Okay, so now so let's go through over again, right? We went over how this GeoParquet file processing happened, but now what you're under the Crunchy Data Warehouse umbrella, you're seeing all of it, right? You're doing the PostGIS materialized views, you're doing nearest neighbor, or you're integrating QGIS. Is just simple and very straightforward from single seamless integration. And this is, again, just wanted to point out, I've just demoed GeoParquet, but when I did Phospho-G, I demoed JSON, CSV, same thing, same concept, creating a foreign table, and able to ingest data. And now I'm very excited to see how we can get all of the other data and more use cases come on board with Crunchy Data Warehouse. So here is my summary, and I'm almost end of it. We talked about the zero to low ETL code for processing in Postgres, SQL and PostGIS, seamless integration, visualization, QGIS, PG admin, and you can use DeckGL and a lot of other stuff. I think that is it for today. I hope you enjoyed it, and let's hope this was helpful.
I did very much. Thank you much, Rekha. And you've done some work with pulling data out of Michigan. How fast did that go to pull? Actually, did you pull data out of Michigan, or did you filter it from all of Michigan?
I filtered it in Michigan. So
Right.
if you can see here, that's another one. I continued. It was filtering on the bounding box, basically.
Right.
What it was. It was filtering on the bounding box, and that's it.
Yep.
And then I created the materialized view, which was, maybe it's in my presentation. If you look at this, this is the materialized view, and this is the bounding box. And I pulled all of that data got pulled into PostGIS.
Right. So the magic is you're addressing 300 gigabytes of data without having to load 300 gigabytes of data.
Correct. And the query for the golf course was directly going towards the Parquet file.
Yeah, same story, addressing all the points of interest without having to download the points of interest.
Correct.
Yeah. The magic of foreign data wrappers only applied in this case to GeoParquet. Super cool. All right. Not seeing any questions to the side. I'm going to say thank you so much, Rekha.
Thank you very much.